Imagine being able to send and receive messages across a staggering distance of 350 million kilometers, or 218 million miles, using lasers. This remarkable achievement has been made possible by NASA's Psyche spacecraft, which has successfully communicated with ground stations on Earth. This innovative leap in optical communication technology is paving the way for high-speed data transmission that could be crucial for future human missions to Mars. But here's where it gets controversial. While traditional radio waves have been the go-to method for deep space communication, NASA's recent advancements in laser technology could revolutionize how we connect with distant spacecraft. NASA's Deep Space Optical Communications Initiative has showcased its ability to transmit data encoded in laser beams over vast distances, demonstrating that such technology can effectively send, receive, and decode information after traveling through the solar system. Managed by the Jet Propulsion Laboratory (JPL) in Southern California, the Psyche spacecraft was launched in 2023 with the ambitious goal of orbiting and studying the metallic asteroid known as 16 Psyche, with its scientific operations set to commence in 2029. Equipped with a sophisticated laser transceiver, Psyche is designed to communicate with 2 ground stations on Earth. To establish a reliable connection, JPL's Table Mountain facility directs a powerful 3-kilowatt laser beam toward the spacecraft, enabling Psyche to accurately lock on to Earth's position. Even though light travels incredibly fast, it still takes several minutes for the laser signal to cover the immense distance between our planet and the spacecraft, both of which are in constant motion. Once the optical data reaches Psyche, it sends a response back to Earth, completing the communication loop. To detect this faint signal from such a distance, scientists utilize the Palomar Observatory in San Diego County, which houses a massive dome capable of picking up the faintest light signals from across the solar system. The incoming photons are then processed through a sophisticated detector array, where the data they carry is meticulously decoded, transforming those subtle flashes into comprehensible information. Optical communication is not entirely new. It has been employed in previous space missions. In fact, this recent achievement marks the 65th and final test of this cutting-edge technology. Traditionally, spacecraft have relied on radio waves for communication, which is still how we receive data from the Voyager 1 and 2 probes, iconic missions that have ventured beyond our solar system since the 1970s. However, laser communications offer a significant advantage. They can transmit a far greater volume of data at much higher speeds. In a fascinating demonstration of this technology, scientists successfully streamed an ultra-high-definition video from a distance of 31 million kilometers, approximately 19 million miles, in December 2023. The video, which features a delightful 15-second clip of a cat playfully chasing a laser dot, showcases the potential of laser communication in a fun and engaging way. NASA technology tests hardware in the harsh environment of space to understand its limits and prove its capabilities, stated Clayton Turner, Associate Administrator of the Space Technology Mission Directorate at NASA headquarters in Washington. Over 2 years, this technology has exceeded our expectations, achieving data rates comparable to those of typical household broadband internet and transmitting engineering and test data from record-breaking distances. In this latest achievement, the laser signal traveled an impressive 350 million kilometers, surpassing the average distance between Earth and Mars, which is about 225 million kilometers, or 140 million miles. This suggests that with further refinements, this technology could facilitate communication between Earth and Mars, where NASA and other nations are planning to send human astronauts in the near future. Imagine the possibility of live streaming a human astronaut walking or even playing golf on the Martian surface. NASA is setting America on the path to Mars, and advancing laser communications technologies brings us one step closer to streaming high-definition video and delivering valuable data from the Martian surface faster than ever before. Technology unlocks discovery, and we are committed to testing and proving the capabilities needed. What do you think about the shift from radio to laser communications in space? Could this be the future of interplanetary communication, or do you believe there are still challenges to overcome? Share your thoughts in the comments.